So we did the hands-free driving system for our project. Our customer was Mr. Davenport with Ground Speed Analytics. Our instructor was Dr. Cheng. Ben Robbins, was the project manager. Our project facilitator was Akansha Day. Our customer liaison was Katie Elbis. Our artifacts manager was Joseph Kaza, and our security manager was Dylan Boyd. So the hands-free driving system is a semi-autonomous system built on top of adaptive cruise control that allows the driver to remove their hands from the wheel when in a highway or a freeway. The motivation for this project is many crashes are caused by driver inattentiveness and driver fatigue, especially on long trips on freeways and highways. Our solution was the hands-free driving system, which, as I previously stated, allows the driver to remove their hands from the wheel, which allows them to sit more comfortably to try and help reduce driver fatigue. It will also monitor the driver's attentiveness so that and alert them if they're not paying attention. And that way, the driver will maintain attention more readily.
So the hands-free driving system is comprised of many subsystems, and together they're responsible for some of the major functionalities. Firstly, the hands-free driving system is expected to validate road conditions, current trajectory, sensor input, and the predicted path using LiDAR mappings and BluePath. The hands-free driving system accepts driver input and displays various warnings when the driver is inattentive or the system is about to relinquish control to the driver. In fact, it gives the driver 3 different warnings, and if the driver still does not regain control after the final warning, then the vehicle stays within the same lane, but it starts braking and comes to a stop, and then eventually puts on hazard lights. The hands-free driving system also uses cameras to monitor the driver's head and eye movement to determine attentiveness. It uses infrared cameras and checks for eye and head looking forward or within a given range that we have determined to be 0 to 90 degrees, with 0 degrees being the leftmost side of the windshield. And finally, the hands-free driving system maintains vehicle position and speed and accelerates or brakes when to maintain the speed. The vehicle also maintains a following distance that trumps its speed maintenance. Therefore, if it is following a car that is traveling slower than the set speed, the vehicle slows down below the set speed to maintain the proper following distance from the car.
Now we're going to walk through a demonstration of how our system works. This demonstration can be found at our website at the link at the top. Our prototype has different functionalities for controlling the vehicle, including steer, brake, and gas, and environment conditions that can be toggled down at the bottom to see how our system reacts in different environments. Now to start with a perfect scenario of hands-free driving working, we're going to accelerate to our speed of 35 miles per hour on our freeway that has a proper LiDAR mappings, engage auto cruise control, and then hands-free driving. In our perfect scenario, the driver would continually give attention about every 5 seconds or less than every 5 seconds in order to continue with no problems until they wanted to steer. Say the driver then hits heavy traffic in this next scenario.
Regain control of the vehicle.
They are then forced to regain control of the vehicle and drive as they manually should because our speed has dropped below the 20 mile per hour minimum in order to maintain hands-free driving. Once the heavy traffic has let up, the driver can then accelerate, turn on auto cruise control, and begin hands-free driving again and constantly give attention. Now in our third scenario, we can imagine that the driver falls asleep, so they are no longer paying attention. The driver is first warned with a pay attention and a flashing green light.
Pay attention.
Then they have a flashing red light and a vibrating seat.
Regain control of the vehicle.
Then they are warned to regain control of the vehicle.
The vehicle is coming to a stop.
If they fail to do so, the vehicle will slow down to 0 and turn on the hazards and come to a stop.
Finally, we would like to thank everyone involved in our project, especially Mr. Davenport and Dr. Cheng. Thank you.